Alrighty, let's get cruising. So if I need to write an equation in both slope-intercept form and point-slope form, what needs to be my first step on this problem? The slope. I gotta find that slope. That's when we're gonna use our formula where we find the change in the y's over the change in our x's, the difference in the y's over the difference in the x's, or where we take our y's to y2 minus y1 over x2 minus x1. That one is sideways. There we go. We're looking at how the y's change, how the x's change. Remember, this is our rise over 1. The rise always has to do with the y's. The rise, the y's. They rhyme. Okay, so to find our slope in this particular case, we're going to take our y values, which would be 10 and 2, and subtract them. And we're going to have 5 and 1 and subtract them. If you do it with the 2 and the 1 in the front, that's totally fine. As long as the 10 and the 5 are together and the 2 and the 1 are together. Because what we have here is 10 minus 2 gives us 8. 5 minus 1 gives us 4. 8 over 4 simplifies down to be what? Careful. Say it again. 2. 8 divided by 4 is 2. It's early. Zero judgment, y'all. It's like Planet Fitness in here. Judgment-free zone. Now that I have my slope and I have a couple of points, I can make point-slope form easy peasy. Point-slope form is that one where we have our y minus y1, m quantity x minus x1. And we put the point, whichever one we pick, into the x1, y1. So when we do that, we're going to have y minus, and I'll go ahead and use this one. Ooh, this one. Not for any particular reason. Just luck, I guess. I don't know. Y minus 10 equals our slope of 2 times the quantity x minus the x value from that point, 5. There's point-slope form. We could do another point-slope form. Y minus, and this time I will use this point. That was not the highlighter. This point. Y minus 2 equals the same slope, blue 2, x minus 1. It's equally as valid. It's exactly the same. It's for the same line. It's just using a different point. Both are valid. Totally fine. I have 2 different point-slope forms. Both of them should simplify down to be the same slope-intercept form. To find slope-intercept form, what we're going to do is we're going to take one of these and multiply it out. Give me some more space. So simply because I have it on the bottom, I'll use this one. So what do I need to do to get this into slope-intercept form?
Distribute the 2.
Distribute the 2. Y minus 2 equals 2x minus 2. What do we do next? Add 2. Yeah. I'm adding this 2 to both sides to get my y by itself, because slope-intercept form has my y by itself. Y equals 2x, what? Plus 0. You don't have to put the plus 0, but if it helps you see stuff, that's fine, because what is my slope? 2. Well, not the 2x, just the 2. Yeah, no worries. What's my y-intercept? 0. It doesn't have one. This is equally as valid if we write this as y equals 2x. So it'll start right at 0. We'll go up to right 1. Up to right 1. Okay. Any questions on that? Is there some like that on the review? Speaking of the review. Nope, not that one. I've got 2 reviews in here today. What do you guys want to work through? And some of these are gross, and I do have the answer key for the review up on Canvas. So if you would rather have independent work time, that's fine. What's up, Eric? What are you doing? Number 3. Yeah, that one's really gross. To be fair, I did not write this review. And just to be safe to say, I will be editing it for next year, because, ew. Because what do we need to do here for an absolute value? Whenever I see an absolute value and it says solve, this is when we isolate, split, and then solve both. So our first step needs to be to isolate our absolute value. Get the absolute value by itself. What can I do to get that absolute value by itself? Minus 13 from both sides. That's going to give me 2 absolute value 4 minus x equals negative 4. Then what do we do? Divide by 2. And we get the absolute value of 4 minus x equals negative 2. Questions on that part? These things were wonky. That's it. So our absolute value, what that's talking about is the distance. How far away? It's how many steps. I talked about my watch a lot on that day. Can I take negative 2 steps? No. Can I have a distance of negative 2? No. We can't have a negative distance. So an absolute value cannot equal a negative number. So we can stop right here and say this system, or this absolute value, has no solution. It's not possible. It's unsolvable. Yes, dear. Say it a little bit louder for me. If an absolute value, when it's isolated, equals a negative number, no solution. So there's a lot of caveats in that. But yes. So let's do one that's a little less weird. Let's do number 4 or 5. I don't care which one. Just so we can do the absolute values right there. Which one do you want, 4 or 5? 4. So we're going to have the same steps. Isolate, split, solve. This time we will actually get to practice more than the isolating. So what do we do to get our absolute value by itself? Plus 8 on both sides. Make this thing smaller. There we go. So we have 3 times the absolute value of 2y plus 4 equals 40. What do we do next? Divide everybody by 3. Absolute value of 2y plus 4 equals, and 40 over 3 doesn't really simplify. You can either keep it as 40 over 3, or you can put it into a mixed number, which is 13 1/3. Whatever works better for your brain. The yellow calculators will work well with the fractions, and it'll work well with the improper fractions, so I recommend the yellow calculators. But it's your call. In fact, I'm going to open the yellow calculator so we have it in the background so I can show you how to do that particularly. Because we've isolated here. Once we get our absolute value all by itself, this is when we split it into our two cases. We're going to take it, and it's going to be that our 2y plus 4 straight up equals 40 over 3. Like nothing's different. The absolute value bars didn't do a dang thing. Or it could be that the absolute value bars were working their tails off, and our 2y plus 4 actually equals negative 40 over 3. So that's where we have our split. So we isolated our absolute value, then we split it into our two possible cases. From there, we just come in on each of these and solve each one of them. What do I do to get y by itself here? Subtract 4. And if we don't want to deal with that as a fraction, I totally get that. So we can go, this is the yellow calculator. It's the same button, same order. Second column, third one down. This button right here is our very bestest friend. It has an N over D. I'm going to push that, and it lets me type 40. I'm going to hit the down arrow over 3. If I hit that right arrow, it brings me out, and I can say minus 4. And it'll spit it out as a fraction. Entirely workable. So we get 28 over 3. So we have that 2y equals 28 over 3. How do I get y by itself? Divide by 2. I'm going to go back to that calculator. And I'm going to take what I have here and divide by 2. 14 thirds. So the yellow calculators will do it for you and simplify. 14 over 3, or if you like it as something a little bit more sane, 4 2/3, or 4.6666666666 repeating. And this is one of our answers. Because then we got to come over here and do this one. It's the same process. We're going to subtract the 4 from negative 40 over 3. So I'm going to come back to my calculator and I'm going to start again. So second column, third button down, N over D. The negative button that we use is way down here at the bottom. Use this one, not this one. This is negative, this is subtraction. I know they look very, very similar, but they are different thoughts. So negative 40 over 3 minus 4. And we get negative 52 thirds. So we have 2y equals negative 52 over 3. Same process, get the y by itself, so we divide by the 2, and I'm going back to my calculator. Divide by 2. And we get negative 26 thirds. Oh, that's 60 degrees. Which, if you like that as a mixed number, is negative 8 2/3. I don't care if you do it as whole numbers or fractions or decimals. It should not be this fractiony tomorrow. That's on my list to do today, is to double check it is not this fractiony. Because holy cow, is this too fractiony. Okay, but if we can do it with the fractions, it'll be all right. Yes, dear. Number 6, yeah. So if we can, number 6 is just like the bell work one we just did. Find the point that goes through the two, or find the line that goes through the 2 points. So find our slope and plug it in. We'll do it, but it's just like the one we did in the bell work. But for number 4 and number 5 works really well as a decimal. I'll make sure they're not quite that gross tomorrow. So let's look at number 6. This is very much like the bell work. Find the slope, find the equation for the line that goes through -8, 5 and 16, 2. This is where we're going to find our slope. Thank you, sir. Finding the change in our y's over the change in our x's. That's all the triangle means is change. So we take and find the difference of our y's. So I'm going to do 5 minus 2. In fact, let me color code stuff. So I will do this point blue. I will do this point green. So I'm going to take my 5 minus 2, the y values from those 2 points, and -8 minus 16. We do not crisscross. The blue point stayed together, the green point stayed together. They've got to be twinsies, matched up. That's going to give me 5 minus 2 gives me 3. On the bottom, I have -24, which is gross, but it's a thing. And we want to look and see if that can simplify, because it's really kind of gross as it is. This is another time when our yellow calculator is really handy, because I can come on in here to that second column, third one down, and do 3 over -24, and it'll simplify it for us. It'll simplify it for us. So our slope is -1/8. Slopes will probably be, can be very fractiony. I would make sure our values don't go fractiony, but the slopes definitely probably will be fractioning. But we're asked to write an equation, not many, just one. We're going to pick one. So that's when we take our slope and one of our points to write our equation, just like we did in the bell work. Y minus the y value from one of our points, which is 5, equals our slope of -1/8 x minus the x value from our point, plus 8. Minus -8 becomes plus 8. And that's an equation right there. I'm 100% happy with that being the answer. You can do it with the other point, also fine. It'd be y minus 2 equals -1/8 x minus 16. You could solve it around in a slope-intercept form if you're feeling real froggy, but you don't know how to. This one, it just said find me an equation. One equation. What else do you guys want to do? Nine. Substitution. Ooh. There's 8. There's 9. All right. So this one, it says use substitution to solve. They gave me 3x plus 2y equals 24, and x equals 3 plus y. So they gave us an x equals. That means I know x equals this. I can take this and substitute in place of my x in the other equation. I'm going to zoom that in so you can actually see that. So what we're going to do is we're going to take our left equation, the 3 times x, and I'm just going to blow my x up so I have a lot of space here. Plus 2y equals 24. 3 times something plus 2y equals 24. Well, that something, that x, actually is 3 plus y. Because I'm substituting the 3 plus y in place of the x. What do we do from here? Distribute. Giving me 3 times 3, which is 9, plus 3 times y, which is 3y, plus 2y equals 24. Now what? Combine like terms. So we're going to have 9 plus what? 5y. These are on the same side of the equal sign. It is combined like terms smashed together. Do not do opposite sign. Now what? Minus 9 from both sides. I have that 5y equals 15. So what does y equal? 3. Ooh, and we're done, right? No. I need an ordered pair, which means I need something to pair the 3 with. How can I figure out what my x is? Yeah, take the y value I found and put it into either one of the dang equations. It don't matter. You can use whichever one you want. The lazy way is to take my x equals 3 plus that y value I found, which is 3. What does my x equal? So my solution to this system is the ordered pair 6, 3. Ordered pair. Put it in parentheses. Yes, you must. What else do you guys want? How about that story problem? 11. Let's look at 11. So we've got Jordan here makes and sells wallets. They estimate that their income is modeled by this equation. Y equals 21x minus 250. And their costs are y equals 9x plus 182. So this was their cost and their income. Oh, no, I have those 2 words backwards. But that's okay. It doesn't really make a difference. And they want to know when they break even. They want to know when their income equals their cost. I want to know when they're the same. What can we do to solve this?
equal to each other?
Yeah. We're going to do it. It's like substitution. It feels weird, but it is substitution. I know that y equals this. So let's substitute it in place of here. We're going to substitute it up here. So we're going to have our 9x plus 182 set equal to 21x minus 250. The ones where we have 2y equals feel weird when we do substitution. I don't know why, but they do. So that's why I wanted to go through one. What can I do down here to solve this? Minus the 9x. Exactly right. Minus 9x. Minus 9x. There we go. So I have 182 equals 21 minus 9 gives me 12. Minus 250. Then what? Plus 250. So I have 12x equals, and we can use a calculator, no shame in that game. 182 plus 250, 432. What do I do to solve for x? By what? By 12. Divide by 12. 36. Do I need to go back and solve for y? Are we asked about that? Or are we only asked about how many wallets?
Yeah.
Only asked how many wallets. If you want to go back and figure out what the cost or what the income would be at that point, that's totally fine. You can. But all we're asked is how many wallets does he need to make? So how many wallets does he need to make? 36 wallets. After 36 wallets, he's turned in a profit. It seems low for a craft business, but that's okay. So these ones where we have 2y equals feel awkward, but it's the exact same process. It's substitution. Okay. How else we feeling? We got about 10 minutes left. Go ahead, Eric. 12. Let's look at 12. Ah, the inequality. So the first request is to get this guy in slope-intercept form. It's smushing a few things together. We're going to get this in slope-intercept form first, which means I need y by itself. What do we need to do in order to get y by itself here? Minus what?
Minus 4x.
Minus the 4x. Minus the 4x. That's going to give me that 6y is less than or equal to minus 4x plus 12. I can't combine them together. We're just going to put them next to each other. Then what do? Divide by 6. Yeah. Y is my sign going to change or stay the same? Stay the same. Yep. Because I'm dividing by a positive number. It only changes when we divide by a negative. So we have negative 4 divided by 6x plus 12 divided by 6. And if you need to write that step out, that's totally fine. Y is less than or equal to negative 4 over 6 simplifies down to be 2/3 x plus what is 12 divided by 6? 2. So step 1 was to solve it into slope-intercept form. Now we're asked to graph our system. So I'm going to graph this guy blue. Are we going to be using a solid line or a dotted line?
Dotted. No, solid.
Solid line. How do we know that? Because it's got this equals to line. If there's a line underneath, we're drawing a line. Where do I start? 2 on my y-axis. How do I move? Down to right 3. Down to right 3. Down to right 3. Down to right 3. The more points we have, the easier it is to connect it up, especially when you're using digital tools. But the more points we have, the easier it is to connect them up. So then we're going to do our line. So let me do that. Oh, it will let me do it here. Sometimes this program doesn't like me to do lines. So there's the line part. Then we got to figure out where the coloring is. We've got to shade part of it. How would we know that? Okay, cool. Just making sure we were guessing that. Yeah, we take a point that's not on our line. 0, 0 is a lovely option. We can either substitute it in here or way up here. So minus 4 times 0 is 0. 6 times 0 is 0. 0 is indeed less than 12. So this side has our solutions. So our solutions are down here. So graph number 1 looks like this. That's this guy. Then let's do this one. Make that brighter. There we go. This says x is greater than 3. So what's this one going to look like? Where is x equal to 3? Do we have a y-intercept here? No, we don't. So it's never crossing this y-axis. X is 3 is right here. If x is stuck at 3, it can't go left, it can't go right. It's stuck right at 3. Y can be anything, but x is stuck at 3. So what is this going to look like? A vertical line. And it's a vertical dotted line, because I heard that part too. So we're going to have a dotted line that's straight up and down, like this. When you have an x equals, it's a vertical line. On which side of the line are the places where x is bigger than 3? To the right. So we color to the right. So our solutions for this system are in this kind of purple area down here. So that's the last piece of this, is we are asked to look at this list of points and tell me if they are solutions or if they are not solutions. So the easiest way to do that is to take your pen, plot it, and put your pen on it. So 4, -2. That's 4, -2. This guy right here. Is this a solution? Yes. So, yeah, that one's a solution. How about 3, 0? No. Because it's on a dotted line, it doesn't count. So that one is not a solution. How about 6, 1?
No.
No. How about -2, 7?
No.
It's way up here. It's not anybody's solution. It's in the white space. What about -6, 0? That's wrong. There we go. -6, 0. That one. I mean, I was wrong either way, but still. And then how about 1, -6?
No.
Nope. That wasn't the laser pointer. I'm like, why isn't it showing up? 1, -6 is right here. So we only had one in this list that actually was a solution, and it was that very first one. So it's important to check them all. Just because one is doesn't mean any others are. Okay? So the test is tomorrow. The answer key for the review guide is up on Canvas. It's posted. We have like a minute until announcements start. Okay? Work on stuff. Ask questions. If you got questions throughout the rest of the day, feel free to shoot me an email or a text or whatever. But tomorrow's the day.